If you want to know where the next leap in autonomous and household robots will come from, don't just look at AI models or mechanical design. Look at the battery. Because the difference between a robot that demos well and a robot that lives in your home, day in and day out, is measured in watt-hours, charge minutes, and cycle life. Today, lithium-ion still rules. It's compact, powerful, and proven. But the hottest advances are pushing well beyond what we've come to expect. Silicon anodes, solid-state electrolytes, and smarter cell designs are nudging energy density higher, increasing cycle life, improving safety, and cutting charge times. In cutting-edge tests and reviews, we're seeing targets of more than 400 watt-hours per kilogram and cycle life stretching into the thousands. That matters because a robot that runs longer, charges faster, and lasts more years transforms how often it can help, how naturally it can fit into the rhythms of a home, and how affordable it becomes over its lifetime. Let's break this down in practical terms. First, energy density. That's how much energy you can store for a given weight. For a household robot, this is freedom. It's the difference between a humanoid that needs a pit stop every couple of hours and one that can clean, carry, fold, and fetch for most of a day. Advances in silicon-based anodes are one of the big reasons densities keep rising. By replacing some graphite with engineered silicon, cells pack in noticeably more lithium. In practice, that can mean a 30% bump in runtime in the same space, or a lighter pack for the same runtime. For robots, that lets designers shift weight lower for better balance, or shrink a torso pack to free up space for cooling, wiring, and compute. Now, safety. This is where solid-state batteries promise a step change. Instead of a flammable liquid electrolyte, they use a solid, ceramic, polymer, or hybrid. That's inherently more stable, much more resistant to thermal runaway, and it opens the door to using lithium metal anodes for even higher energy density. You've probably heard timelines from major automakers talking about solid-state packs hitting the road late this decade. Those same characteristics, higher energy per liter, safer chemistry, and fast charge capability, map perfectly to indoor robots operating around people, kids, and pets. A safer, cooler running pack means simpler thermal management, quieter operation, and more flexible placement inside a robot's torso, hips, or backpack module. What about charging? This is the heartbeat of autonomy in the home. If a robot can get from 10% to 80% in 10 to 15 minutes, it changes the daily workflow. Instead of long off-duty windows, you get quick top-offs between tasks, vacuum the downstairs, dock for 10 minutes, then handle the kitchen, then dock again before carrying laundry. In lab and early pilot results, solid-state and advanced lithium metal adjacent designs are already demonstrating ultra-fast charging windows. And even in today's lithium-ion, better electrolytes and pack architectures are bringing faster charge rates without cooking the cells. For household robots, the goal is simple: whenever the robot's idle, it should be sipping charge efficiently, with minimal battery stress. Let's talk about sodium-ion, because this is getting real. Sodium-ion isn't a replacement for everything. It's a complementary chemistry that shines when cost, supply resilience, and safety matter more than absolute energy density. For indoor robots that spend most of their time near a dock, or service bots that shuttle short distances all day, sodium can be a smart choice. It's less resource constrained, potentially cheaper, and it's good enough for short-range duty cycles. Imagine budget-friendly home assistants or elder care companions that don't need marathon runtimes because they can opportunistically charge throughout the day. Sodium-ion helps bring those price points down without compromising on safety. Now, put yourself in the shoes of a robot designer. You need to fit a battery into a compact torso or base, balance weight for walking or stair climbing, dissipate heat during bursts of power, and keep the center of mass stable when the robot lifts a box or bends to pick up a toy. Higher energy density helps with form factor. Safer electrolytes help with thermal design. Longer cycle life means you can size the pack for typical daily use instead of overbuilding it for fear of early degradation. And better fast charge capability means you can design around short, frequent charging instead of long nightly sessions. This isn't theoretical. Robotics leaders are already treating batteries as core infrastructure, not afterthoughts. Integrated packs shaped to the torso. Liquid cooling channels designed with the battery in mind. Battery management systems tuned for bursty loads, like going from idle to a heavy lift, then back to idle. The shift is from buy a shrink-wrapped pack to co-design the robot with its battery, because that's what unlocks real-world reliability. Let's connect this to specific household tasks. Vacuuming and mopping draw steady power for locomotion and suction plus pumps. Folding laundry is start-stop, bursts of torque for grasping and manipulating, then lighter loads while vision and planning do their work. Kitchen assistance combines all of it: mobility, dexterous manipulation, and constant perception. Each task benefits from batteries that handle high peak currents without voltage sag, stay cool under burst loads, and recover quickly, ideally while the robot docks for a quick charge during planning or transitions. The right chemistry and pack design make these transitions smooth and invisible. And don't forget life cycle. A home robot is an appliance you expect to keep for years. Cycle life in the thousands isn't a luxury, it's critical to total cost of ownership. If you charge twice a day, a 2000 cycle pack gives you about 3 years before noticeable capacity fade. A 5000 cycle pack pushes that out towards 7 years. Couple this with improved recycling and second life pathways, and the economics start looking closer to other major home appliances. Let's make a short, practical roadmap, focusing on what it means for robots in the next few years. Over the next 1 to 3 years, expect steady gains from silicon anode blends, smarter battery management, and pack integration that squeezes a bit more runtime and enables faster top-offs. Expect more sodium-ion in cost-sensitive devices where weight isn't critical. And expect robot makers to normalize quick charging habits, dock early, dock often, rather than deep discharges. Between 3 and 5 years, if solid-state timelines hold, we'll see the first wave of safer, higher-density packs move from pilot to meaningful deployments. For household robots, this translates to slimmer waistlines, quieter cooling, and more graceful motion because packs can be placed where they help balance instead of where they must fit. Charging windows shrink, which makes continuous service possible. A robot does a task, tops off, then another, almost like a human grabbing a quick snack between chores. Beyond 5 years, as manufacturing scales and costs come down, expect a split in the market. Premium assistants and humanoids move to high-density, safe chemistries, solid-state or lithium metal adjacent, designed for all-day service with short pit stops. Budget models lean into sodium-ion or other cost-optimized chemistries with robust packs, longer cycle life, and simpler thermal systems. And across the board, smarter battery analytics, predicting health, optimizing charge schedules, and balancing cell loads will reduce downtime and extend usable life. Let's address the elephant in the room. Will household robots really become common, and do batteries make or break that outcome? Yes, they do. Even with great AI, if a robot spends a third of its day charging, if its pack degrades after a year, or if it runs hot and needs noisy fans, it will feel like a gadget, not a teammate. Batteries are the enabler for human-scale cadence, breakfast help, school run tidying, lunch prep, afternoon pickup, dinner assistance, and evening reset, with short, quiet charges threaded throughout. That's what feels magical, a robot that's present when you need it, discreet when you don't, and reliable for years. So what should builders and buyers watch? 1. Practical energy density, what the whole pack delivers, not just a lab cell. 2. Safe electrolytes and pack abuse tolerance, because homes are chaotic. 3. Fast charge capability that doesn't punish cycle life. 4. Thermal behavior under peak loads. And 5. Transparent battery health metrics, so you can plan maintenance before it becomes a problem. Where are we headed? toward robots that feel less like devices and more like dependable helpers. The battery is how we get there: safer chemistries for peace of mind, higher densities for graceful form factors, faster charging for continuous service, and longer cycle life for real economics. Pair that with better charging docks, quiet, reliable, maybe even built into furniture, and you'll barely notice the energy layer. You'll just notice that the floors are cleaner, the kitchen is tidier, and the laundry gets folded, even when your day gets messy. In the end, the hottest advances in battery technology are not just numbers on spec sheets. They're the foundation for a new class of autonomous and household robots that work when you do, rest when you do, and fit into the background of your life. That's the future we're charging toward, quietly, quickly, and safely.